In this note we're going to talk about circles. And we can start with the definition of a circle. A circle is defined as the set of all points in a plane that are the same distance from a fixed point. So if you think of how a compass works, you put a point down here and you have a fixed length that the pencil is away from the point. And then you just sort of trace around, never changing the distance from the center to the outside. Well, we know that the distance from any point to the center is called the radius. Now, if the center of the circle is at the origin of the Cartesian plane and the radius is our units, then we can say, since the radius is the distance, that any point has the property the square root of x squared plus y squared, which is the distance, is the radius. Okay, so the square root of x squared plus y squared, which is the distance from the center, is the radius, because that's exactly what these points are. The distance from any one of these points to the center is the radius. And so we're saying the distance is the radius. Now if we square both sides of this equation, if I take this and square it, what I get is the square root of x squared plus y squared times the square root of x squared plus y squared. And when you do that, all you're left with is x squared plus y squared. Okay, when you square something that's square rooted, you're left with the value in the inside because it's positive. And if we square the left hand side, we have to square the right hand side. So we get r times r, which is r squared. Well, lo and behold, that's the equation of a circle. So if you square both sides of that equation, you get x squared plus y squared equals r squared. And therefore we can say that the equation of a circle centered at the origin with a radius of r is this. This is something you want to memorize and remember it well. We have it written in red there for you. That's the equation of any circle with a radius of r centered at the origin. So what we're going to do now is a few examples. First we're going to write the equation of a circle that has a center at the origin and a radius of 3 units. Well, it would be x squared plus y squared equals r squared. Since r is 3, we can say the equation of the circle is x squared plus y squared equals 3 squared. We simply plug in a 3 for r. And 3 squared is 9. So we can say the equation of the circle is x squared plus y squared equals 9. Well, what if the radius is 1/3 units? Well, then instead of saying x squared plus y squared equals r squared, we plug in 1/3 for r. Since 1/3 times 1/3 is equal to 1/9, we can say that the equation of the circle centered at the origin with a radius of 1/3 is x squared plus y squared equals 1/9. Okay, now I want you to imagine that we have a circle that's defined by the equation x squared plus y squared equals 9. We want to sketch a graph of that circle. Well, if x squared plus y squared equals 9, that means that r squared is equal to 9. And that would mean that r was the square root of 9, which is 3. And so what we want to do now is draw a circle with a radius of 3 centered at the origin. So there's the center, and there are some points on the outside of the circle, and we're going to connect them. This might not be the greatest looking circle of all time because I'm doing it freehand, but we're going to connect them and make a circle of radius 3. That circle has the equation x squared plus y squared equals 9. Okay. Now, for our next question, we're going to imagine that a circle has a center at the origin and passes through the point 8, -6. What we want to do is find the equation of that circle. And then we want to know the coordinates of the other endpoint at the end of the diameter passing through 8, -6. Well, we can start by figuring out the equation. We've got x squared plus y squared equals r squared. Well, just like we would have done in grade 9 with straight lines, what we're going to do in grade 10 with circles is we're going to substitute in a value for x and a value for y. X is 8 and y is -6 because we know the point 8, -6 is on the circle. So plugging in an 8 for x and a -6 for y, we get 8 squared plus -6 quantity squared equaling r squared. That means 64 plus 36 equals r squared. 64 plus 36 is 100, so 100 equals r squared. And since x squared plus y squared equals r squared is the equation of the circle, and since 100 is r squared, we can say the equation of the circle is x squared plus y squared equals 100. Okay. Now the next question is to determine the coordinates of the other endpoint at the end of the diameter passing through 8, negative 6. So what we're going to do right now is imagine we've got the point 8, negative 6 right there. And we're going to draw a diameter. That means we're going to draw it through the origin. And basically what we're being asked for are the coordinates of that point way out there. And one relatively easy way to do this is we can see that what we've got are two different triangles, and we can see that this length, this side length, is going to be equal to this side length. Well, since this y value is negative 6, this side length is 6. The length of it is 6, and that means the length of this is 6. And since it's going up from the x-axis, it's going 6 units up, we can see that our y-coordinate will have to be a positive 6. Now let's look at our our horizontal length. We see that this length right here is equal to 8. And this length is going to have to equal this length because of the symmetry of the triangles. So since this side length is 8, this side length is also going to have to be 8. But this is going in the negative direction for x. So we can see that the coordinates out here would have to be negative 8, 6. If the coordinates here were 8, negative 6. Because what that would do, since we're given this, we'd be able to say you go up 6 and over 8, and then you go over 8 and up 6. And you end up exactly across from where you started. So the answer to the question is negative 8, 6. That is the end point of the diameter going through 8, negative 6. Our next question says a stone is dropped into a pond and sends out a circular ripple whose radius increases 5 centimeters per second. And we want to find the equation of the circle 12 seconds after the stone is dropped. Well, we know that distance is equal to speed times time. The speed is 5 centimeters per second and the time is 12 seconds. So the distance that ripple has traveled outward is 60 centimeters. Well, that's like a radius. Think of a ripple. When you throw a stone in a pond, it ripples out. Where the stone hit is the dead center of the circle that gets created. And the radius of 5 centimeters per second, moving out at a speed of 5 centimeters per second for 12 seconds, will therefore be 60 centimeters. So if r equals 60, we can say that r squared is 3600. And since x squared plus y squared equals r squared, therefore the equation of the circle is x squared plus y squared equals 3600. And for our last question, we want to know whether the point 9, negative 5 is inside or outside a circle with an equation of x squared plus y squared equals 100. Well, the best way to do that is simply figure out how far away 9, negative 5 is from the origin. So we can evaluate. X squared plus y squared is 9 squared plus negative 5 squared. But remember what x squared plus y squared represents. We can say that the distance is equal to the square root of x squared plus y squared. The distance of the point 9, negative 5 from the origin is given by the square root of x squared plus y squared, which is the square root of 9 squared plus negative 5 quantity squared, which is the square root of 81 plus 25, which is the square root of 106. So the distance of that point to the center is square root 106. Well, since the distance is square root 106, and since the square root of 106 is greater than the radius of 10, which this circle has, because 106 is bigger than 100, root 106 is bigger than 10. So since this distance is bigger than the given radius, the point in question must be outside the circle. X squared plus y squared equals 100.